You think you know how fast you're going. You glance at the dial before you, 60 miles per hour, let us say, and you accept this number as fact, as truth, as a measurement of something real about your state of being in this moment. The wheel turns, the road passes beneath you, and you believe you have answered the question, how fast am I moving? You are mistaken, not slightly mistaken, fundamentally mistaken about what that number means and what it fails to mean. That dial measures one thing only, your motion relative to the Earth's surface, nothing more. It tells you how quickly you move with respect to the road beneath your wheels. But here is what it does not tell you, what it cannot tell you, your motion relative to your seat, relative to the book in your lap, relative to the sun around which this Earth orbits, relative to the distant stars. And here is the revelation that will transform how you understand motion itself. Relative to your seat, you are perfectly, absolutely still. Relative to the sun, you hurtle through the void at 67,000 miles per hour. Relative to the center of our galaxy, faster still. All of these speeds are simultaneously yours. Each is perfectly real. Each is perfectly true. They do not contradict one another, for they measure different relations. The single number on your dial is not your speed. It is one speed selected from infinitely many. Consider the gentleman reading in a smooth-moving carriage. He turns the pages of his book undisturbed by velocity. His hand is steady. His coffee, were he to set it upon the table, would remain level and still. He feels no wind, experiences no sensation of forward motion whatsoever. To every fibre of his being, he is at rest. Now step outside that carriage and stand upon the roadside as it passes. Watch that same gentleman through the window. From where you stand, he moves 10, 20, 30 miles per hour, while you remain fixed to the earth. Which perception tells the truth? Both do. This is not paradox. This is precision. The reader is genuinely at rest relative to his book, his seat, the walls of his carriage. He is genuinely in motion relative to the road, the trees, the man standing by the roadside. Neither observation requires correction. Neither is illusion. Both describe the actual state of affairs with perfect accuracy. The error most make is believing one measurement captures real motion, while others are mere appearance. They imagine the man in the carriage is really moving at 30 miles per hour and only seems to be still relative to his seat. But this is precisely backwards. Both measurements describe reality. Neither possesses privilege over the other. Whence it follows that the single number you accept as your speed is a confession of arbitrary choice. Not a lie, precisely. The measurement is accurate for what it measures, but a profound incompleteness masquerading as complete truth. You possess not one speed. You possess infinitely many speeds, simultaneously, each measured against a different reference body in the cosmos. Your dial selects one, Earth relative motion, by convention, by practical necessity, by the accident of what surface you happen to travel upon. But nothing in nature makes Earth relative motion more real than any other measurement. Tonight, when you lie in your bed believing yourself at rest, know this: you have travelled thousands of miles since morning as the Earth rotates upon its axis. You have travelled farther still as the Earth orbits the Sun, and the Sun itself moves through the galaxy, carrying you with it at velocities beyond easy comprehension. Your stillness relative to your mattress and your tremendous velocity relative to the Sun are both real. Neither cancels the other. Neither is more true than the other. They simply measure different relations. Consider what happens when light passes through a prism. A single beam of white light, apparently simple, apparently uniform, reveals itself as composed of many colours. The apparent unity was simplification. The multiplicity was real all along. So too with speed. What appears as a single property, your velocity, reveals itself upon proper analysis as a compound of infinitely many measurements, each taken against a different reference. The dial shows you one colour, so to speak, while hiding the full spectrum. Now imagine waking in a windowless chamber, with no means of observing anything outside. By what experiment could you determine whether you move smoothly through space or remain at rest? Drop a ball. It falls straight down. Light a candle. The flame burns unchanged, pointing neither forward nor backward. Pour water from one vessel to another. It behaves exactly as it would on solid ground. Every test you can devise yields identical results, whether you move uniformly through space or stay perfectly still. The question, "Am I moving?" posed without reference to any external body, has no empirical answer. Nature refuses to distinguish between uniform motion and rest. This is not a failure of your instruments. This is not a gap in your ingenuity. This is the structure of reality itself. Before this chapter, you believed you possessed one speed, the number on your dial, the answer to a simple question. After this chapter, you must recognize that you possess infinitely many speeds simultaneously, and that the question itself was never as simple as it appeared. The single number has become a doorway to infinite multiplicity, and this multiplicity raises a deeper question. If you possess infinitely many speeds at once, which is your true velocity? Is there any measurement that captures your authentic state of motion through the cosmos? Or does the very question betray a misunderstanding more profound than any single wrong answer could? The question seems innocent enough. How fast am I really going? Behind this question hides an assumption so deep that most never notice they are making it. The assumption is this, that beneath all the relative measurements, 60 miles per hour relative to the road, 0 relative to your seat, 67,000 relative to the sun, there lies one true velocity, your actual speed, your authentic motion through the cosmos. This assumption names nothing that exists. There is no absolute speedometer hidden in the fabric of reality, recording your true velocity. There is no privileged reference point from which genuine motion can be measured, while all other measurements are revealed as mere appearance. The question, "How fast am I really going?" is not difficult to answer. It is impossible to answer, because it asks about something that does not exist. You have many speeds. You have no true speed. Consider two ships approaching each other at sea. Between them exist 10 knots of closing velocity. The distance between them diminishes by 10 nautical miles each hour. Captain A, standing upon the deck of the first ship, declares, "That vessel approaches me at 10 knots. Captain B, aboard the second ship, insists with equal conviction, "No, that vessel approaches me at 10 knots. Which captain speaks truth? Both do. Neither does. The question reveals its own malformation. There is no fact of the matter about which ship really moves. There is only the relation between them, a closing distance, a diminishing separation, and this relation can be equivalently assigned to either ship or both, or split between them in any proportion you please. All descriptions predict identical observations. All are equally valid. None possesses privilege. Ask, which ship really moves and which really stays still? And you ask a question without meaning. It resembles asking, which direction is left, without specifying whose left you mean. The question lacks necessary information and therefore lacks possible answer, from which it appears that absolute velocity names no observable phenomenon. It is not that we lack instruments sensitive enough to detect it. It is not that the signal is too faint or the measurement too difficult. It is that there is nothing there to detect. The concept is empty, a word without referent, a question without answer. This may trouble you. The mind resists it. Surely, you think, somewhere there must be solid ground, some fixed point against which true motion can be measured. Perhaps if you escaped the earth entirely, floated in the void between celestial bodies, you would finally know your true state, moving or at rest. But no, in perfect isolation, velocity has no meaning whatsoever. Motion requires something to move relative to. Remove all reference bodies, and you remove the concept itself. You cannot ask whether you move through empty space, because moving through empty space names nothing. It describes no detectable state, no observable condition, no phenomenon accessible to any experiment. The error here is believing in a privileged observer, a God's eye view from which absolute measurements can be taken. We imagine that someone, somewhere, could see the truth that all our relative measurements merely approximate. But this privileged position does not exist. Every observer occupies a frame. Every frame is as valid as any other. None transcends the relational structure of motion itself, and therefore the question, how fast am I really going, must be dissolved rather than answered. Watch what happens when this dissolution occurs in practice. Two travellers in separate carriages pass one another on the road. Each sees the other moving. Neither sees himself moving. An argument might ensue. You passed me. No, you passed me. The observer who grasps what motion actually is sees immediately that both speak truth. Each describes the relation from his own frame. The disagreement was never about fact. It was about unexamined assumptions regarding whose frame possesses authority. No frame possesses authority. The dispute dissolves, not into one being right and one wrong, but into recognition that both describe the same relation from different vantages. This is not relativism in the sense of anything goes, or truth is whatever you believe. The relation between the carriages is perfectly real. Their closing or separating velocity can be precisely measured and predicted. What dissolves is only the false assumption that one description is really true, while the other is merely apparent. Is it not evident that this principle extends beyond physics? When two observers report different experiences of the same event, how quick we are to assume one must be wrong. Yet perhaps both describe the same reality from different reference frames, different positions, different relations to the phenomenon in question. Perhaps the disagreement dissolves not into one being correct, but into recognition that reality admits multiple true descriptions. But we must proceed carefully here. Not all claims are equally valid. Some observations are simply mistaken. The principle of relational description does not license any claim whatsoever. It licenses only those claims that accurately describe the relation from the frame in which they are made. The captain who reports a closing velocity of 10 knots speaks truth. The captain who reports 20 knots has made an error of measurement or calculation. Relations are real. They constrain what can accurately be said. But which ship really moves? That question admits no answer because it assumes something, absolute motion, that does not exist. Before this chapter, you sought the real answer to how fast you move. You believed such an answer existed, waiting to be discovered by sufficiently careful inquiry. After this chapter, you recognize that the question itself was malformed. The search ends not in discovery, but in dissolution. What remains? If absolute velocity does not exist, what does exist? If speed is purely relational, how do we construct understanding from pure relation? The false foundation has crumbled. Now we must discover what can be built in its place. Let us now construct understanding from proper foundations, proceeding as natural philosophy demands, from phenomena to principles, never outpacing what observation can support. Motion is not a property that inheres in any body. It is a relation between bodies. This statement is not philosophical abstraction. It is not metaphysical speculation. It is the precise description of what observation reveals when we examine phenomena with sufficient care. Consider, by what means do you know that anything moves? You observe its position change relative to other bodies. The carriage moves because its distance from the trees diminishes. The ball falls because its height above the ground decreases. The planet orbits because its position among the stars shifts from night to night. Remove all reference bodies, all trees, all ground, all stars, and motion becomes unobservable, not hidden, not difficult to detect, but meaningless. Moving and stationary possess no sense except in reference to some other body chosen as standard. And here is the profound consequence that follows from this recognition. Nature herself treats no reference frame as privileged. Drop a ball from the mast of a ship sailing smoothly across calm waters. To observers aboard, the ball falls straight down, landing precisely at the mast base, exactly as it would on solid land. To observers standing on the shore, watching the ship pass, the ball traces a curved path through the air, moving forward even as it descends. Both descriptions are correct. Both predict exactly where the ball lands. The laws governing falling bodies operate identically, whether you measure from the moving ship or the stationary shore. This is not coincidence. This is principle. Every experiment conducted within a smoothly moving vessel produces identical results to the same experiments at rest. Light a candle, the flame burns unchanged. Swing a pendulum, it traces the same arc. Drop, throw, pour, measure. Nothing within the vessel can reveal whether it moves or remains still. Whence it follows that nature does not distinguish between uniform motion and rest. She treats both states identically, governing both by the same laws, producing in both the same phenomena. No experiment conducted inside a closed cabin can determine whether that cabin moves uniformly through space or sits motionless upon the earth. This is not a limitation of our instruments. This is not a temporary gap in knowledge awaiting future technology to fill. This is the structure of how nature reveals herself, and therefore we must recognize what motion actually is, not a property of individual bodies, but a relation between them. The ship does not possess motion as it possesses mass. The ship possesses motion relative to the shore, relative to the water, relative to the stars. Change the reference and you change the motion, not because you have corrected an error, but because you have measured a different relation. Now consider what this means for measurement itself. The navigator charting his course never asks where his ship truly is in some absolute sense. He asks where it lies relative to landmarks, relative to stars, relative to currents and coastlines. Every calculation involves relation. The navigator who demanded absolute position before setting sail would never leave port, for absolute position does not exist. Yet the navigator reaches his destination. His relational calculations guide him across vast oceans with remarkable precision. Relation is not impoverishment, it is the actual structure of reality, and it suffices for all practical purposes. Observe how skilled practitioners in every domain understand this implicitly. The astronomer measures planetary positions relative to the sun. The surveyor measures land relative to fixed points. The merchant measures value relative to currency. All specify their references because they understand, whether they articulate it or not, that measurement without reference is meaningless. What we now make explicit is what observation has long demonstrated. Relation is not a veil concealing some deeper absolute truth. Relation is the truth itself. As white light passing through a prism reveals itself as composed of many colours, so a single speed reveals itself as composed of infinitely many measurements, each relative to a different reference body in the cosmos. The apparent unity, my speed, was simplification. The multiplicity, infinitely many speeds, one for each possible reference, is real. This is not loss, this is abundance. You possess not one speed, but infinitely many. You are simultaneously stationary, relative to your seat, moving at walking pace, relative to your companion beside you, hurtling at thousands of miles per hour, relative to the sun. All true, all real, all measuring different relations. For one day, practice this. Whenever you notice or state a speed, pause to identify the reference. That carriage moves at 20 miles per hour, relative to what? The road. But the road moves relative to the Earth's centre, which orbits the sun, which circuits the galaxy. Trace the chain of references. Notice how every speed rests upon chosen reference, and how changing that choice changes the number without changing reality. The error most persistent here is treating relational description as second best, as what we settle for when absolute description is unavailable. But relational description is not poverty. It is infinite richness. It is the actual structure of how nature operates. Before this chapter, you might have seen relational motion as a limitation, the best we can do when true velocity lies hidden. After this chapter, you see relational motion as the actual structure of reality. The limitation was the illusion of the absolute. What remains is richer than what was lost. But a question persists. If no experiment can distinguish uniform motion from rest, did natural philosophers simply accept this? Or did they search for ways to detect absolute motion through space itself? What happened when that search was undertaken in earnest? The search for absolute motion was not foolish. It was principled, rigorous, and entirely appropriate to natural philosophy rightly conducted. Consider the reasoning. If space itself existed as a kind of substance, an invisible medium filling the void, a framework against which all motion occurred, then motion through this medium might produce detectable effects. Bodies moving through space might experience resistance, however subtle. Light might behave differently, depending on whether its source moved through space or remained at rest. Some phenomenon, some observation, some experimental result might finally reveal absolute velocity. Natural philosophers hoped for this. Some expected it. The search proceeded with full rigour, examining every phenomenon that might discriminate between motion and rest. The search found nothing. Consider a ship sailing smoothly across calm waters. Within the ship, every phenomenon behaves identically to how it would behave on solid ground. Drop an object. It falls straight down relative to the deck, landing at your feet. Pour water from a pitcher. It flows as it would in a stable room. Light a candle. The flame burns vertically, undisturbed by any forward motion. Observe any process whatsoever. It proceeds unchanged. The ship might sail at walking pace or racing speed. It makes no difference to any experiment conducted within. The ship might as well be at rest, for all that nature indicates. Now, suppose you objected. Perhaps these experiments are too crude, the effects too small to detect with ordinary observation. Perhaps with more sensitive instruments, absolute motion would reveal itself. But attend carefully to what is being claimed. It is not merely that current instruments fail to detect absolute motion. It is that no conceivable experiment can detect it. This universality is itself data. Here is how to understand this claim. The laws of nature, those principles governing how bodies fall, how light propagates, how forces transmit. These laws take identical form whether you measure from a frame at rest or a frame in uniform motion. Not approximately identical, not close enough for practical purposes, precisely identical. Whence it follows that any experiment you devise, governed by these laws, must produce identical results in both frames. No cleverness of experimental design can overcome this. You are not searching for a faint signal obscured by noise. You are searching for something that does not exist. The distinction here is crucial. Imagine searching for a quiet sound in a noisy room. Difficult, but possible with sufficient care. Now, imagine searching for the sound of something that makes no sound at all. The second search fails not through insufficient effort, but through non-existence of the quarry. Absolute velocity is the silent thing. No phenomenon manifests it. No experiment can detect it, not because our methods are inadequate, but because there is nothing to detect. Yet here we must mark a crucial distinction. Acceleration, unlike velocity, produces detectable effects. The passenger in a carriage rounding a sharp turn feels pressed against the side. The passenger in a carriage suddenly braking lurches forward. The passenger in a carriage accelerating from rest feels pushed back into his seat. These effects are undeniable, independent of reference frame, revealed by sensations within the body itself. But the passenger in uniform motion feels nothing. He cannot determine by any internal sensation or experiment whether he moves smoothly at 30 miles per hour or sits perfectly still. This asymmetry reveals something profound about the structure of nature's laws. Velocity is purely relational, undetectable without reference to external bodies. Acceleration is absolute in its effects. It manifests regardless of frame. You can always tell whether you accelerate. You can never tell whether you move uniformly. This does not rescue absolute velocity. You can detect changes in motion, but not motion itself. You know when you speed up or slow down, but you cannot know whether your current uniform state is really motion or really rest. The distinction between them remains undetectable. Step from a moving carriage onto solid earth. You feel yourself decelerating. The change from carriage velocity to ground velocity produces unmistakable sensation. You believe you have passed from motion to rest. But have you? The earth itself spins on its axis at considerable speed. It orbits the sun far faster. The sun moves through the galaxy. You have merely changed reference frames, trading motion relative to the carriage for motion relative to the earth. You have not found absolute stillness, for no such thing exists. Suppose you could escape to the deepest void between stars, far from any matter whatsoever. You float in perfect darkness, no stars visible, no bodies to reference. Are you moving or at rest? The question dissolves. You can perform no experiment that would answer it. Motion requires something to move relative to. In perfect isolation, stripped of all relation, the concept loses all application. You are neither moving nor at rest. You simply are. Some imagine that if instruments were sensitive enough, absolute motion could yet be detected. This is not a matter of instrument sensitivity. It is not that the signal is too weak, but that there is no signal. The absence is not limitation of technology. It is feature of nature herself. Before this chapter, you might have hoped that somewhere, somehow, absolute motion could be found, that the relational structure we observe is merely practical limitation, hiding a deeper, absolute truth. After this chapter, you understand that the search has been conducted with full rigor, and the result is unambiguous. Uniform motion through space is empirically indistinguishable from rest. This is not defeat, this is discovery. The failure to find absolute motion reveals something profound. The laws of nature possess a deep symmetry. They take the same form for all observers moving uniformly relative to one another. But if velocity produces no detectable effect, while acceleration clearly does, what accounts for this difference? What does acceleration reveal that velocity conceals? Acceleration unmasks itself, where velocity remains hidden. This asymmetry lies at the heart of how nature operates. The passenger moving uniformly feels nothing. No force, no pressure, no indication of motion whatsoever. But introduce acceleration, change the speed, change the direction, and effects become undeniable. Consider a bucket of water suspended from a twisted rope. Release the bucket, and it begins to spin. At first, something curious happens. The bucket turns, but the water within does not immediately follow. The water surface remains flat while the bucket walls rotate past it. The water has not yet acquired the bucket's rotation. Gradually, friction between water and bucket communicates the motion. The water begins to spin with the bucket, and as it does, its surface curves, rising at the edges, depressing in the center. Now here is the question that reveals everything. What causes this curvature? It is not the motion of the bucket relative to the water, for when bucket and water rotate together, there is no relative motion between them, yet the surface remains curved. The curvature persists even when bucket and water move as one. The curvature manifests the water's rotation, not relative to the bucket, which now rotates with it. The rotation itself, the acceleration required to maintain circular motion, produces effects that transcend choice of reference frame. You can always detect whether something accelerates. You can never detect whether something moves uniformly. This distinction is not arbitrary. It reflects the fundamental structure of nature's laws. The passenger in a carriage feels every turn, every start, every stop. His body is an accelerometer, exquisitely sensitive to changes in motion, utterly blind to uniform motion itself. Press him against the side as the carriage rounds a bend. He knows, he accelerates. Let the carriage proceed straight and steady. He cannot tell whether it moves or rests. Whence it follows that acceleration produces effects. Velocity does not. Change of motion manifests absolutely. The motion itself is purely relational. Throughout any journey, attend to your body's sensations. Note, when you feel pushed or pulled, these are accelerations. Note when you feel nothing. These are periods of uniform motion or rest. You can always distinguish the first category from the second without looking outside your conveyance, but you can never distinguish uniform motion from rest by internal sensation alone. The error here lies in believing that because acceleration is detectable, velocity must be detectable too, if only we try harder. But these are fundamentally different things. Acceleration involves change, and change produces effects. Velocity describes a state, and states, uniform states, produce no effects by which they can be detected. Consider, you can feel the difference between cold water and hot water because temperature is a property that manifests to your senses. But can you feel how fast you travel through space? You cannot. Not because your senses are inadequate, but because uniform motion through space produces nothing to sense. The water in the spinning bucket curves. This curvature would occur in an empty universe, visible to no observer, measurable by no external reference. The curvature is absolute, not absolute in the sense of true versus apparent, but absolute in the sense of independent of reference frame. It manifests regardless of who observes or from what vantage. Velocity possesses no such absolute character. Velocity exists only in relation to some chosen reference. Change the reference, and you change the velocity. No experiment can reveal which velocity, which reference frame, represents the true state. But acceleration's effects transcend reference. The curved water surface, the force pressing you against the carriage wall, the lurching sensation of sudden stopping. These occur regardless of how you choose to describe the motion. They are the traces that acceleration leaves upon the world. This distinction will prove essential to understanding nature's deeper symmetries. The laws that govern motion take identical form in all uniformly moving frames. This we have established. But frames that accelerate are different. Acceleration breaks the symmetry, introduces forces, produces effects by which it can be known. You can always tell when you accelerate. You can never tell when you merely move. Before this chapter, the difference between velocity and acceleration might have seemed technical, a matter for specialists in natural philosophy. After this chapter, you understand it as fundamental. Velocity is relational and undetectable. Acceleration is absolute in its effects and undeniable. This asymmetry is not puzzle to be solved, but truth to be accepted. And now the scattered insights of our inquiry begin to coalesce. Motion is relational. Velocity cannot be detected. Acceleration manifests absolutely. The laws of nature take identical form in all uniformly moving frames. But understanding principles separately is not the same as seeing how they weave together. How do these truths about motion connect to broader patterns in nature and knowledge? What does this relational structure reveal about measurement itself, about how we know anything at all? The pieces await assembly. The unified vision approaches. What we have learned about motion extends far beyond motion itself. This is where the inquiry deepens, where a principle about velocity reveals itself as a principle about reality. For the relational nature of speed is not an isolated peculiarity. It illuminates the structure of measurement itself, the very means by which we come to know anything at all. Consider how you determine the length of any object. You place a measuring rod beside it. You count how many times the rod fits along its extent. The number you obtain, 3 feet, 5 cubits, 7 spans, describes not a property belonging to the object alone, but a relation between the object and your chosen standard. Change the standard, and you change the number. The object remains unchanged, yet its length becomes different. This is not paradox. This is precision about what length actually means. A relation between the measured and the measure. Whence it follows that length, like velocity, is relational. Now consider weight. The merchant places grain upon one pan of his balance, counterpoise upon the other. When the beam levels, he declares the grain weighs 5 pounds. But what has he measured? He has measured a relation, the grain's gravitational attraction compared to the counterpoise's gravitational attraction at that particular location. Move to a mountaintop where gravity pulls slightly less and the same grain weighs less. Carry it to a valley, and it weighs more. The grain itself remains unchanged. Only the relation changes. Weight is relation. Length is relation. Time requires a clock, another relation between the process measured and the regular motion chosen as standard, from which it appears that no measurement reveals an intrinsic property belonging to the measured object alone. All measurement reveals relations between the measured and some standard, some reference, some basis of comparison. This is not limitation. This is the structure of how knowledge becomes possible. The laws of nature themselves are relational statements. The law of gravitational attraction relates one mass to another across distance. The force between them depends upon both masses and the space separating them. Remove either body and the force has no meaning. The law describes relation, not intrinsic property. The laws of motion relate force to acceleration, mass to resistance, action to reaction. Each law speaks of how things stand in relation to other things. Nature's grammar is the grammar of relation. She speaks not of isolated substances, but of connections between them. And now push this insight further. If all our measurements reveal relations, and all our laws describe relations, then what can we say about the objects themselves, apart from their relations? The question grows murky. Consider any object you please. What properties belong to it, in isolation from all other objects? You might say it possesses mass, but mass manifests only through gravitational attraction to other masses, or through resistance to forces applied by other bodies. You might say it possesses extension, but extension is measured only by comparison with other extended things. Strip away all relations, and what remains? Perhaps nothing we can name, perhaps nothing we can know. Perhaps relation is more fundamental than substance. This need not alarm us. We need not mourn the loss of intrinsic properties we never actually possessed knowledge of. What we know, what we have always known, are relations. And relations suffice. Observe how every quantity you encounter involves implicit reference. This room is 20 feet long, relative to the foot standard. This journey takes 3 hours, relative to the hour standard, defined by some regular motion chosen as clock. This object weighs 10 pounds, relative to the pound standard. The references are so familiar, we forget they are there. But remove them, and the numbers dissolve into meaninglessness. 20, without specification of units, means nothing. 3, detached from reference to some regular process, tells us nothing about duration. 10, without a standard of weight, is mere abstraction. Select any measurement you encounter today and trace its relational structure. What standard defines it? What comparison makes it meaningful? Could the number exist without the reference? Notice how the web of relation underlies all quantitative understanding. Notice how removing relation removes meaning. The error most persistent here is believing that relational knowledge is second best, a substitute for absolute knowledge that we cannot quite attain. We imagine that real knowledge would tell us what things are in themselves, apart from all relation, and that our relational knowledge is merely the shadow of this inaccessible truth. But consider, what would absolute knowledge even look like? How would you describe an object with no reference to any other object, no comparison of size, no specification of position relative to other bodies, no relation to any observer? The very concept becomes incoherent upon examination. Perhaps absolute knowledge is not merely unattainable, but non-existent. Perhaps relation is not the veil concealing truth, but the very structure of what truth can be. The universe may not be composed of things with fixed, intrinsic properties, Like coloured beads strung upon an invisible string, the universe may be the string itself, a web of relations in which what we call things are merely intersections, nodes where multiple relations meet. Motion taught us this first. Motion revealed its relational nature unmistakably, forcing us to recognize that velocity has no meaning except relative to chosen reference. But motion was merely the first lesson. The pattern extends to measurement of every kind. Before this chapter, you saw the relational nature of motion as a special case, a peculiarity of velocity that perhaps did not extend elsewhere. After this chapter, you see it as revealing a universal pattern. All measurement is relational. All quantitative knowledge emerges from comparison. And the cosmos itself may be a web of relations rather than a collection of things with intrinsic properties. But if all measurement is relational, and knowledge arises from measurement, then what becomes of truth? If no one occupies a privileged position for measuring anything, if every observer measures from within the web rather than from some point outside it, how can anyone claim accurate knowledge? Does the relational universe dissolve into mere opinion, where all claims are equal and nothing is true? Or does it offer something more solid? Relational knowledge is not impoverished knowledge. It is genuine knowledge, effective knowledge, sufficient knowledge for every purpose we require. Consider the navigator charting his course across the ocean. He measures his position relative to the stars, relative to the coastline, relative to the compass needle pointing toward magnetic north. Every calculation involves relation. He never asks where his ship truly is in some absolute sense, for he understands, whether he articulates it or not, that absolute position means nothing. And yet, he reaches his destination. His relational calculations guide him across thousands of miles with remarkable precision. He predicts when he will arrive. He avoids hazards. He adjusts for currents and winds, all by measuring relations, and these relations prove entirely adequate for the task at hand. The astronomer who calculates planetary positions relative to the sun predicts eclipses, conjunctions, and oppositions with extraordinary accuracy. He knows where each planet will appear in the night sky, months or years hence. He accomplishes this by relational measurement, describing orbits relative to the sun, positions relative to the background stars. A different astronomer might choose to calculate the same motions relative to the Earth, placing our world at the center of the cosmos as ancient astronomers did. His numbers would differ. His descriptions would sound quite different. Yet if his calculations are correct, he predicts exactly the same observable phenomena, the same eclipses at the same times, the same risings and settings, the same appearances of planets against the constellations. Different descriptions, identical predictions. Each description serves the describer's purposes. Each makes certain calculations easier or harder. But neither captures absolute truth, while the other offers mere appearance. Both describe the same relational reality from different vantages. Whence it follows that knowledge, which enables successful prediction and action, is genuine knowledge, regardless of whether it corresponds to some absolute truth beyond all relation. The navigator reaches his destination. The astronomer predicts eclipses. The architect raises buildings that stand. The farmer plants at the right season and harvests at the right time. All proceed by relational measurement, by comparing what they measure to standards they have chosen for practical purposes, and all succeed. If relational knowledge was somehow deficient, if it grasped only shadows, while absolute truth remained hidden, how could it work so well? How could calculations based on mere relations guide ships across oceans, predict celestial phenomena centuries in advance, construct buildings that endure for generations. The effectiveness of relational knowledge suggests that it is not deficient at all. It grasps what there is to grasp. Relations are real as anything can be. They support prediction. They enable action. They make navigation, astronomy, architecture, and every other practical art possible. We need not mourn absolutes we never possessed. Notice how skilled practitioners never argue about which reference frame is correct. The astronomer who measures from the sun does not criticize the navigator who measures from the earth. Each knows that different purposes call for different references, and that neither choice is more true than the other, merely more useful for particular ends. The astronomer, choosing the sun as reference, simplifies his calculations of planetary orbits. The navigator, choosing the Earth as reference, simplifies his calculations of coastal positions. Each selects the reference that serves his work. Neither claims his frame captures absolute truth, while the other deals in mere approximation. Apply this understanding beyond physics. When two observers report different experiences of the same event, how quick we are to assume one must be mistaken. Yet perhaps both describe the same phenomenon from different reference frames, different positions, different backgrounds, different relations to what occurred. This does not mean all claims are equal. The navigator who calculates incorrectly runs aground. The astronomer who errs in computation predicts eclipses that do not occur. Relations are real. They constrain what can accurately be said. Wrong predictions reveal wrong descriptions, regardless of what reference frame was chosen. But disputes about which frame is really correct, which observer occupies the privileged position from which truth can be seen, these disputes dissolve. They were never about fact. They were about unexamined assumptions. Two errors threaten here, and both must be avoided. The first error is believing that without absolutes, we sink into formless relativism, where all claims are equal, and nothing is true. But relational knowledge is not anything goes. Relations are real. They support some claims and refute others. The navigator who calculates correctly reaches port. The one who calculates incorrectly does not. Reality constrains what can be said, even when reality consists of relations rather than absolutes. The second error is believing that some reference frame must be really correct, even if we cannot determine which one. This is the error of assuming absolute truth exists while confessing we cannot access it. But why assume this? What evidence supports the existence of a privileged frame that forever eludes our measurement? Perhaps the very concept of absolute truth, truth independent of all relation, description from no particular vantage, is incoherent. Perhaps truth was always relational, and we simply failed to notice because our local relations seemed so stable, so unchanging, so much like solid ground beneath our feet. If no observer occupies a privileged position for measuring motion, perhaps none occupies a privileged position for other judgments either. This suggests humility, not the humility of admitting we fall short of absolute truth, but the humility of recognizing that perspective is intrinsic to knowledge, not a defect to be overcome. Before this chapter, you might have worried that relational understanding undermines truth, leaving us adrift without anchor. After this chapter, you see that relational understanding redefines truth without undermining it. Truth becomes what enables successful prediction and action within the web of relations, and this is sufficient. This is all we ever had. This is all we need. Understanding that relational knowledge is genuine knowledge clears the ground for the deepest question. How does this transformed understanding change how we experience the world? Knowing differently should mean seeing differently. What does relational perception look like in daily life? Understanding changes seeing. This is not metaphor. This is not merely philosophical prettiness. The person who genuinely grasps the relational nature of motion experiences the world differently than one who does not. Return to where we began, the dial reading 60 miles per hour. Before this inquiry, you saw a simple fact, your speed. Now, you see a doorway. That single number opens onto infinite others. Your speed relative to your seat, 0. Relative to the sun, tens of thousands of miles per hour. Relative to each star in the firmament, different for each. The number has not changed. Your perception of what it means has transformed. Every speed you encounter now reveals this multiplicity. The carriage passing at 20 miles per hour, relative to what? The road. But relative to its own passengers, it moves not at all. Relative to the Earth's centre, the speed differs. Relative to the sun, enormously more. Each perspective valid, none privileged. This transforms how you understand disagreement. Two travellers argue about which carriage approaches which. Each insists the other moves while he remains still. Before, you might have sought to determine who speaks truth. Now you see immediately. Both speak truth. Each describes the relation accurately from his own frame. The disagreement was never about fact. It was about unexamined assumptions regarding whose frame possesses authority. No frame possesses authority. The dispute dissolves not into one being right and one wrong, but into recognition that both describe the same reality from different vantages. Is it not evident that this principle extends beyond physics? When observers disagree about what occurred, how quick we are to insist one must be wrong. Yet perhaps both describe the same event from different reference frames, different positions, different histories, different relations to the phenomenon in question. Perhaps the disagreement dissolves not into one being correct, but into complementary perspectives on shared reality. This does not mean all claims are equal. The navigator who calculates wrongly crashes upon rocks regardless of his sincerity. Reality constrains what can be said. But which frame represents the true view? That question may have no answer, for it may rest on the same false assumption we have exposed in motion, that truth exists independent of perspective, somewhere outside all vantage points. Humility follows from relational understanding. If your speedometer reading is no more real than any other measurement of your motion, perhaps your perspective on other matters is equally partial. Perhaps the view from your particular vantage point, however accurate within its frame, does not exhaust what can truly be said about the subject. This is not weakness. This is accuracy. This is seeing your own position for what it is. One vantage among many, one relation among infinite relations, valid but not uniquely privileged. The richness of multiplicity now becomes visible. Before, you possessed one speed, or so you believed. Now you recognize you possess infinitely many speeds simultaneously, each true, each measured against a different reference. This is not poverty. This is abundance. The single number was impoverishment, though it felt like certainty. The infinite multiplicity is richness, though it may feel at first like loss. The same transformation applies to position. You occupy one location, you think, but location relative to what? Relative to your chair, you are here. Relative to the city centre, there. Relative to the sun, somewhere else entirely, changing moment by moment as the earth orbits. You stand not in one place, but in infinite relations, one for each body in the cosmos to which your position might be compared. The web of relations is not something external you move through. It is what you are. You are a node where countless relations intersect. Wonder survives this transformation. Indeed, it deepens. The cosmos that once seemed full of fixed properties, objects with definite speeds, positions, weights, now reveals itself as a web of relations, each intersection a new perspective, each perspective valid, none privileged. This is not diminishment. The cosmos as web of relations is more marvelous than the cosmos as collection of fixed properties could ever be. For the web is infinite. Every body relates to every other. Every measurement reveals one strand, while infinite others remain available. The simplicity we sought, absolute speed, absolute position, absolute truth. That simplicity was impoverishment, masquerading as clarity. The complexity we have found is glory. Practice this transformed perception. For one day, whenever you hear a comparison, faster, larger, heavier, longer, ask, compared to what? Notice how often the reference remains implicit, assumed, hidden. Notice how making the reference explicit clarifies apparent disagreements, dissolves false disputes, reveals complementary perspectives where contradiction seemed to reign. When disagreement arises about motion, position, or any matter of comparison, pause before insisting on your rightness. Ask, what reference frame generates my observation? What generates the others? Might both observations be accurate from their respective vantages? The error to avoid here is believing that relational understanding makes you passive or indecisive. If all perspectives possess validity, how can you choose among them? How can you act? But practical life requires choosing reference frames. The navigator chooses Earth. The astronomer chooses the sun. Each chooses what serves his purpose. Understanding that the choice is necessary does not prevent making it. Only false certainty about the choice's absolute correctness departs. You remain free to act. You remain capable of judgment. You merely recognize that your judgment proceeds from a frame that others might not share, and that their different judgments might be equally valid from their different frames. Before this chapter, you saw the world through a single implicit reference frame, believing it the real one. After this chapter, you can see through many frames deliberately chosen, recognizing each as valid for its purposes. The world has not changed. Your capacity to perceive it has expanded. But having transformed perception, one final question remains. What is the ultimate significance of this understanding? Beyond practical application, what does relational motion reveal about the nature of reality and our place within it? We began with a simple question. How fast are you going? The question seemed innocent. It invited a simple answer, a number, a measurement, a fact about your state of motion. But the inquiry that followed has opened onto vistas far beyond what that simple question suggested. Speed is relational. This we have established beyond doubt. But the principle extends further. All measurement is relational. Length requires a measuring rod. Weight requires a balance. Time requires a clock. No measurement reveals intrinsic property. All reveal relation between the measured and some standard. Push further still. Perhaps the universe itself is not composed of things with fixed intrinsic properties, but of relations among things. Perhaps what we call objects are intersections in a vast web of relations, nodes where countless connections meet rather than independent substances that happen to interact. If this is so, and the evidence points that way, then our place in the cosmos takes on new character. We are not observers standing outside reality, taking measurements of things that exist independent of our observation. We are participants in the web. Our measurements are relations we enter into, not views from nowhere. We do not stand apart from the cosmos examining it. We stand within it, one node among countless others, related to all else. This is not limitation. This is our nature, and it is glory. The night sky, once a dome of fixed lights, now reveals itself as a vast arena of relative motions. Every star moves relative to others. Every galaxy recedes or approaches relative to its neighbours. Nothing stands still absolutely. Everything moves in relation to something else. The earth beneath your feet, seemingly so solid and fixed, hurtles through space at speeds beyond easy comprehension, relative to the sun, relative to the galactic centre, relative to distant galaxies receding at the cosmos's edge. Your stillness as you stand upon it is real, perfectly real, relative to the ground beneath you. Your tremendous velocity is equally real, relative to the sun. Both true, neither complete. You are simultaneously the slowest and fastest thing you can perceive, depending on which relation you choose to measure. This simultaneity is not paradox. It is precision about the nature of motion. It is recognition that speed does not inhere in you like colour in cloth. Speed describes your relation to other bodies, and you stand in infinitely many such relations, each yielding a different number, each equally true. Tomorrow morning, lying in your bed, know this: you have travelled immense distances through space while remaining perfectly still. Your stillness relative to your mattress and your tremendous journey relative to the sun are both actual, both accurate, both descriptions of your single existence from different frames. Let this knowing become seeing. Let this understanding transform not merely what you think about motion, but how you perceive it. See the multiplicity directly, not as abstract knowledge, but as lived experience of the cosmos's relational structure. Imagine, if you can, viewing the cosmos from every reference frame simultaneously. Every speed, every position, every relation perceived at once. This is impossible for finite beings. We can occupy only one frame at a time, measure only one relation at once. Complete knowledge would require occupying every vantage simultaneously, and this we cannot do. But recognizing this impossibility reveals something important about our condition. We possess one vantage among infinitely many. We are one thread in an infinite web. We see one facet of inexhaustible complexity. This limitation is not failure. It is our situation and our dignity. We do not stand outside the web taking God's eye measurements. We participate in the web related to all else, seeing from our particular intersection. This participation is not second best. It is the only knowledge finite beings can possess, and it suffices. The great ocean of truth lies yet undiscovered before us. Each measurement we make, each relation we trace, reveals some portion of that ocean. But the ocean exceeds all our measurements. Reality exceeds all our reference frames. We are not diminished by this excess. We are enlarged by contact with it. The boy finding pebbles on the shore is not impoverished because the ocean stretches infinite before him. The pebbles are real, smooth, beautiful. The ocean's vastness gives them context, reveals what remains to explore. So it is with our knowledge of motion, of measurement, of the cosmos itself. What we grasp is genuine. What remains exceeds what we grasp. Both facts together describe our situation accurately. The final error to avoid is melancholy, mourning the absolute certainty that never existed. Some, upon learning that absolute speed is empty concept, feel bereft. They wanted solid ground, fixed points, certainty beyond perspective. And now they learn that no such certainty exists. But this morning mistakes the nature of what was lost. We have not lost truth. We have gained understanding of what truth can be for finite beings within the cosmos. We have not lost knowledge. We have recognized that knowledge was always relational, and that relational knowledge works, suffices, guides ships, and predicts eclipses and builds cathedrals. The web of relations is not prison. It is home. You began this inquiry believing you knew your speed. One number, one fact, one truth about your state of motion. You end knowing that you possess infinitely many speeds simultaneously, that measurement is relation, that knowledge is participation in the cosmic web, and that this condition is not poverty but inexhaustible richness. You will never see motion the same way again. And perhaps, if you carry this understanding into the rest of your experience, you will never see anything quite the same way again. For the lesson motion teaches that what seems absolute reveals itself as relational, that what seems single reveals itself as infinite. This lesson may apply far beyond the spinning of wheels and the passing of carriages. The cosmos asks not, how fast are you going, but only, how fast relative to what? And to that question, answers multiply beyond counting. Each answer true, each answer partial, each answer one strand in the infinite web that constitutes reality. The measure of motion is always relation, and in a universe of relations, every vantage reveals truth. The great ocean of truth lies yet undiscovered before us. We are not diminished by this vastness. We are enlarged by contact with it.